So, welcome everyone. Hey guys, fine. Welcome back. So, unless you're totally immersed in your classwork right now, I would prefer you to, just listen and contribute to the class environment. Number one, assignment 2, submissions. So, everyone has somewhat submitted, I guess? No? If you haven't, and we know some haven't, it really depends where you are, I'm not sure. Try to submit nevertheless. So you will still get partial points even if it's late. So don't worry about completeness necessarily, just so we get a bit more of a comprehensive picture of how much people actually got from the content we delivered. So even though we are pledging for hard deadlines all the time, some of you may have figured out that they were not that hard at all. But we need to start somewhere, but we still want to see how far you guys got. So it would be still good, even if you have partial code and you're not quite finished yet, or can't manage to implement all features, it would still be worthwhile to submit it. So that's the idea there. And the same will probably count for the last assignment. That said, the last assignment should be a bit easier based on 2 reasons. Number one, that you obviously need to pick a code base to work off from, right? So you are groups of 2 or 3. So you have potentially 3 code bases to work off from, which gives you a little bit more choice, I guess. And yet, yeah, you're 3 people. So ideally, you should have a benefit from that one in terms of making it fairly feasible, that assignment. So it's the key challenge there. Anything else I want to say? Any questions on your part? Yeah. Who did the student barometer thing? Oh, cool. Right. Nice. 3 out of 100. That's pretty good. So what about the rest? Can I convince you to do it as well? Again, you're in for an iPad or something like that, so that should be incentive enough, but even more so should be a better student environment in the future. Anyway, if you haven't, please do so. Would be appreciated by the administration in particular. Coming back to what we are talking about. Last week we talked a bit about Docker. We didn't get too far. We just looked at Docker and had some discussions about how to structure and think about containers. This week, or towards the assignment 3, one of the elements of this were to Dockerize basically your Go application, right? So it's a key idea. Some of you have attempted it already. Who has finished with that already? No one yet. Okay, so if anyone would have suggested that it's would be finished already, then there would be little point of me exploring it. But since you haven't, so we talk about some specifics regarding Go and Docker. So it's not as smooth as it could be for other applications, so we'll probably look at some of those characteristics and then look at how we can structure applications as well. See how far we get. So one of the components that will challenge this a bit is also my development environment, because I need to rebuild it. So so we may have some hiccups along the way. We'll see how that goes. But first of all, I'll just install Go again as a rapid approach. Internet is good, that's good. So last session we talked about 2 things. One of it was, what did we talk about last week? Is there any? We talked about 2 concepts. What were those? It's kind of going towards the exam, so you get the concept right. So that's why I'm asking those stupid questions. Anyone? It's not on the screen here, so. What did we talk about? Just to put you in the right mindset, because I suspect most people were in some sort of assignment 2 world and wrapping that up, which is understandable. But we talked about some other concepts. Anyone? Please.
2 ways of building Docker instances.
Yeah.
One through the Dockerify that it's somehow build on run.
Yeah.
And the other when we run the base of the Docker and just go inside, install things, and save it as a new image somehow?
Yep. Cool. Yes, you're spot on. So we had the explicit way using Docker files, right, where it's explicitly specified what we're doing, and we had the rather implicit way of committing, right, writing to it and committing from it directly, which was kind of, yeah, semi-helpful. What's the upside and downside of the corresponding approaches? What's the upside of the commit approach, of the inline, of the interactive approach? What's the advantage?
It's running the way we made it, so no changes from the base image can affect. So.
Okay, so I wonder what we get at. One of them was we starting and running container, we're entering it and we're doing stuff in it, right? So, and then we commit it afterwards, right? So we had to change container.
It's kind of a snapshot of this stage that we reach.
Yep.
This we accept, and then we want this to be exactly the same later.
Right, exactly. So, but the upside of it is basically that you can do it in real time. You can at runtime, right? The container can continue to run, and you can do, well, modifications, right, and change it and so on. Whereas in the other case, the Dockerfile case, is it offline or is it online modification?
The Dockerfile, it's being built in the runtime. So when somehow that this build this inlogging into the Docker instance that we did in the first case, it's done when the Docker file is run to build a new instance. So, in this first case, it's run once before commit.
Yeah. Okay. Cool. Yeah. So just to clarify those two things, you're on the right track there. And this is Docker run. So we have those two. Again, it's about the two concepts of one having images on one hand and having containers on the other, right? So containers were instances of images, right? So we have a Go environment or an Apache environment. We can spawn 5 instances of those, no harm, right? So it's relatively straightforward. And so the first approach, which was the inline modification, the interactive modification, was really about using a running container, entering it, and then doing modifications, and then committing those modifications into a new image, right? So, but the key benefit here is that we can literally modify the container at runtime. Right? So ideally, we don't have any downtime. Ideally, well, it's not kind of a production environment kind of approach we should take anyway. But that's one of the possible pathways. The other way was simply to do the modifications in the Docker file, build an image from it, and then spawn containers from it. So it's more like, you know, compile time or the kind of like design time operation there. So yes, it all happens in Docker, but this image is not executable, right? So it's only executable once it's built and then subsequently instantiated using Docker run. And so we need to run Docker build and Docker run. In this case, we just committing, and this creates a new container, image in the first place. So those are the two approaches. Just to bear in mind that those two exist. But for your purpose, you definitely would want to fall back to Docker files. It's quite important. Cool. So last session, let's see how that goes here. So last session, we briefly looked at that both approaches for Dockerizing an application, Apache 2 in this case, simply web server. Doesn't really matter. But I think today we probably should be a bit more productive and actually look into something that we can directly relate to, and probably something that you will deal with as well, which happens to be some Go app, I guess, right? So let's continue with that. So first of all, let me check what my Docker, I didn't want to see that. Didn't want to see that either. Hang on. What my Docker instance does. Docker images is, oh, sudo's not, Docker's not found, that's uncool. Oops. Okay. Damn. So much about rebuilding my own development environment. Unclever. But unintended. So let's see where that went wrong. Let us see what went wrong. What is happening here? Sorry for that. We'll need to debug that a bit. Is Docker in Snap? Yeah? Cool, let's do it. I think we're getting there somewhere here though. Very good point. Since we're on it, we talk about this. Yes. Ah, fuck. Yep. Yeah, okay. You're right. We'll see how it goes. Snap install Docker.
I think it's just Docker.
Just do a find. So, okay, cool. So number one, let's briefly talk about what's happening here. So Jonas suggested to use Snap. So Jonas, what's Snap?
It's a package manager.
Cool. So what's the magic about it?
It's so you instead of installing your application and additional dependencies after or before,
yep.
Like you have many dependencies, you install everything in just one thing.
Yeah. Cool. So yeah, so that's precisely what it is. So it's an alternative. You good? Okay.
Yeah.
Yeah. Okay. Yeah. So they usually use apt-get, right? So for installing stuff on Ubuntu or Debian-based system, and it usually is about dependency management there. So one package checks if another package exists and installs it if necessary, and so on. You have a large dependency tree that sits there, and it has some awkward situations that it may actually lead to installing incompatible packages. So if one of your packages, for example, Apache relies on, let's say, Python 2, and another package relies on Python 3, and if those two versions actually don't, work well with each other, you nevertheless need to install both of them to get those packages going, right? And the idea about Snap, or Snappy as that whole concept is called, is to provide self-contained images of applications that include all their dependencies. The downside is there that now every application that, for example, uses Python ships its own Python instance, right? So you may have 10 of them on your system, right? But it also means when you remove it that it's clean removed together with your instance, and they are inherently isolated, so it can't affect each other. And we find, where do we see this pattern of installation already?
Docker.
Yeah, Docker is similar, you're right. What else? That's something that we use every day. Apps, right? So phones, phone apps, particularly Android apps. I think most of you downloaded some APK already, somewhere, sometime, and no? Did manually install applications on Android? No? Yes, perhaps? In any case, application or apps on the App Store are distributed as self-contained packages of the very same nature. So they have, obviously they have dependency with respect to the operating system, but since it's so reasonably generic, meaning packages, APKs need to run on multiple Android versions, they are reasonably self-contained, so bring most of the dependencies with them. So it's a very similar concept, and here it's now on server side as well. So we use that one now to install Docker, but somewhat unintended, but thank you for the pointer. That's really helpful. So we see how that goes.
Isn't that horribly inefficient and wastes a lot of disk space?
Yep.
And you have to download a bigger package to get the app.
Yep. But
you save yourself the trouble of managing compatibility. So I guess it's worth it.
So it's really you.
Yeah, it's the trade-off. They figure that it might be worth it to spend more disk space just to make sure your thing always will run, no matter what else happens on the system. Like,
at least for the end user, you don't want them to have to manually install 20 components just to run your game or app or whatever.
That's another thing. I mean, you can automate part of it, but that's another good point. But you know, even yeah, true. Even on Windows, you have this, right? DLL hell and so, things like that. But the motivation is clearly to say, well, how much does outage, you know, how much does an outage cost in a production system composed to disk space? And you quickly figure out that disk space doesn't cost anything anymore, right? So it has become a no-brainer.
It's costly for the user, but not costly for the producer of the like hardware or software. But when the user's like, well, I have 16 gigabytes and I spent 13 on use, like, oh shit, I can barely have like Discord on this thing.
Yeah, well, yeah, but yeah.
I have images.
Admittedly, there's certainly this element, but I mean, usually when we have server-side applications, they're usually not that weighty in terms of their you know, execution engine compared to games. Games is a different story, right? If you're talking, you know, tens of gigs of libraries and stuff, and you know, assets and all that kind of related images, it's a different story. But here we're talking really rather megabyte sizes, and given nowadays ability to, you know, work on with firstly differentiated disk space on AWS, you can define whether you want to have, you know, slow disk space or rather fast disk space, and this basically brings your cost down as well. So you pretty much have reasonably unlimited storage at a very affordable price. And even with your own server, it's pretty much a no-brainer to, you know, add 2 4 terabyte disks, and off you go. And instead of having even thinking about having some sort of downtime instead. So it's really like a more convenience tool. But the point is, one tool doesn't affect the other. You can still use apt anyway. So it's really up to your preference. Plus, also it's still, Jonas mentions now production, is it, in 1604 LTS? Is Snap now production? Is it still, I think 7010 or something, right? So it's still experimental somewhat. And they had been actively discouraging for using in production systems. But you know, it's coming ahead, so it's worthwhile knowing about this and being aware of it, I guess. So we try it out and see how far we get here. Hopefully that doesn't. Yep, cool. That looks good. So yep, sweet. All right, so we're back on track. Sudo Docker version. That's just was 17, wasn't it? Yes, cool. Server and client, right? So cool. All right. After solving that one. So one thing we wanted to do, or should do, is actually start Dockerizing something meaningful as opposed to some other people's applications. We need to do it with our own ones. So that will be the next step. So our classical demo application was, Go is installed right now. Yeah, cool. Was the student database. And I'll just bring that up for illustrative purposes. Hang on. GitHub.com IMT2681 cloud. So that thing. Good. So let's get this and see how we Dockerize it. Again, this is an empty instance here. We need to see how far we get with this. So GitHub.com Mani IMT2681 cloud. Probably should do. Sweet. All right. So Go path is properly set, so we can run go install. And so generally, what I recommend you to do in any case, ensure that whatever you actually want to run runs locally first, because it's one thing that actually is not nice as of now is debugging Docker containers, especially if they're not running. There's hardly any way of actually getting into it and solving that. So discourage that. So let's see, student DB. Yeah, we have dependency issues as expected.
Are you inside the Docker now?
Nope.
No.
Nope, I have not started Docker. So what I want to do first is get that thing running before we start that drama. What do we have here? Yep, we need to clean something up. So for example, he has a new folder called talks, which has some errors which we actually don't care about, so let's just get rid of them. RM-R talks, right. Okay, go again. Okay, that's reasonably okay. Do we need PCC? Probably should get around without it. So, all right, go install. Where were we? Hang on. Bring me back my command. That was fast. Good. So, okay. What? Hang on. What do we need to specify in order for it to run? What do we need to specify in order for it to run this application? Hang on. StudentDB. General environment variables. So let's figure those out. Yep, we need to get the port. So let's set it to something. Export port equals 8080, and then we can run StudentDB. And it should hopefully respond to our requests with a bit of. So let's automate some of those requests. That's not the instance I want to get into. Good. So it's the web server. This is still, it's running in OpenStack, so our only meaningful way of actually accessing it is yeah, command line. And to make our testing life a bit easier, it's probably worthwhile having some test files. So for querying and for posting and for getting anything. Hang on. So you guys know the curl command, I guess. And I'm just doing a post request. So we're specifying a header, content type, application JSON. Then a method we want to use. In this case, it's post. And then the URL of choice. HTTP, localhost 8080. Hang on. We cheat a bit here. Hang on. The handler was student. Yeah. Student. -d. And -d means you can specify a body, and that's what we're doing right now. So we need to have the body for the JSON that we want to pass along. For this, we need to know what was the student struct like. Hang on. Name, age, student ID. Okay, let's do that. Name, Peter. On age, always 21. Student ID is yeah, some ID. Okay, cool. Closing one. Closing. And closing semicolon. I hope that thing works. Anyway, so it makes cool query post. So we need to make that thing executable. Right now it's not. How do you make it executable?
Plus X.
Sorry?
Plus X.
Plus X would do, right? Cool. And then query post. Oops, I need to re-sudo to do that. Cool. And then we can just execute this. Cool, we don't get anything back, which may or may not mean something good. Moved permanently, okay. Let's do the same for get. So, get that is H. Hang on, it's probably easier by copying it. Copying query post sh to query get sh. What's cool? Nano query get sh. Pseudo permissions in there. So let's do it here as well. Same thing. In this case, we want to have a get. I don't think it's fussy about it, but let's be precise. We don't need anything else, I think. So just the URL, and we just want to get everything at that URL, so we can just run them in iteration and see what the database has to offer. Okay, get content type JSON. Okay. Not good. So netstat -a. So netstat -a shows you what local ports your machine is bound to, and definitely not 8080. That's not cool. Okay, right. Echo port. That looks good. Ah, this works. So I must have typo in my query gets HTTP localhost 8080 student. Sure, should actually work. So let's see. Post. It says that one if we run get. I don't get anything back, which is not nice. Any thoughts? Sure. Most like that one. was the get one? Hang on, this one. The trading slash, I suspect it is. That's better. So 200, cool. And we have a get, and now we have page data. So so now the data, the student DB is actually running right in memory, default version. After fixing my bugs here, finally we are there. So cool. We have something we can actually hopefully deploy. So let's do a bit of Docker. So that's basically a prerequisite. The idea is they are, once we have that set up, now we can actually build it from scratch, right? For this purpose, we obviously need to get the Docker base image. So where do we find this? Anyone? For Golang? Sorry. Docker Hub will do. So okay, there seems to be 1.9 available, but you get the explicit tags in Docker Hub, so it's the easiest way of finding them. They also show minor versions there. For example, so we take, which one do we take? Not Windows, but this one. So repository is called Golang. So cool. Cool. All right, from Golang. Then the tagged image 191.9.2 stretch was the name. By default, we run updates, upget update, and upget -y upgrade. So we actually have a latest package stage in case that has changed. So since we have Golang in our Docker library, we should also already have a Go path in there, so we can just conveniently change to that one. So we're just setting up the.
What was the -y again?
-y, just confirming the installation. So default option yes. So if you run apt-get upgrade, it will actually ask you whether you want to upgrade, and you can choose, and it's the default selection. Cool. So
wait, you get to go path for free. You don't have to set up the folder.
Yeah, that's the idea of that image here. So because the base image should already set the Go path. If you, for example, build off Ubuntu directly, you wouldn't have it. That's right. But in this case, it's customized for it's a Go environment already. Yeah, one of the benefits of using Docker, obviously. So, cool. So then afterwards we can probably we actually need to let me modify my repository, else it will just break on us. I'll probably fork that. You wouldn't like that. I have an earlier version, hang on. I'll just get rid of that. I actually need to delete it. Annoying. Right. So I'll clean up a bit. So what were the issues we had? GitHub. T2681 cloud. That should be about it. There are talks. What else do I need to do? Was there anything else? No, it was the only thing that basically fell over. Cool. So git status. What happens? Git add. Git commit and deleted talks. I'll probably use my real one. Show. And setting up the username as well. Again, that's a fresh environment, so good and bad, I guess. Requires you to do all that again and again. Deleted links, cool, we did a commit, and then we finally push that thing. So now we have a clean repo. We removed those talks that were giving us trouble, and we're back to our Docker file. So in the Docker file now, we need to get a library of choice, right? So the package of choice. So in this case, it probably would be like that. Actually, we should test that it actually works. That's probably more important. Hang on. Go get github.com IMT2681 cloud. Cool. Go install github.com IMT2681 cloud in the student DB. Wrong. Double 8. That's not happening. Cool. So yeah, that seems to have worked. Right. So we can emulate the same here. IMT2681 cloud cmd student db. Go install, and again cool. And then afterwards we can return to the work directory go path, right? So because that's where we started off from. So right now we were in source. Actually, I wouldn't have needed to go there. Actually, we get around this entirely. Just comment that. And finally, you want to invoke that, and hopefully that gives us the desired output. So from the go path directory in bin student DB, that's what we expect as an executable. Good. Let's be good citizens and declare maintainer. Cool. So it looks like a reasonably straightforward Docker file. So let's see if we can build this. Cool. Yep.
That command that was to run the executable.
Yeah, hang on. If we look into the go bin folder, right? Go path bin, and we run go install, we will we'll find an executable, right? So that's the key idea. And this is the one we need to navigate to from go path. Go path is in /go here for home/go. And in a subfolder /bin, you should find studentdb. So if we run this one, we should be able to actually instantiate it, right? So docker build -t. -t is taking an image. So, and this is the studentdb, and we want to give it a some whatever tag to make it happen. And that's it. Point indicates compile in the current context, meaning look into the current file. Not that it would really matter. Share context, whatever. Room stack bin.
Question.
Yeah, please.
So there is also a possibility to copy files.
Yeah.
The local file system. Should you ever do that in any case, or should you always pull from the Git repositories?
Ah, okay, right. The only limitation I see for using the local file repository is that you need to make assumption about the folder allocation. But if you, for example, put the Docker file into a Git repository, right, and make that downloading of that repository an assumption in the first place, then it's fine.
Most of the time, you probably have the Docker file right next to the source code.
Yeah.
So it's not necessary to download it?
No, in this case it won't be necessary to download, no. In fact, that will be a lot cheaper anyway, right?
Yeah,
so because faster anyway. So no need to. I would even suspect that you'll be able to get more efficient images because you don't have the overhead of downloading into a local, having this additional overhead of downloading the files, not necessarily only the needed files.
Yeah, and in, for example, assignment 3, we have 3 executables. Maybe we have 3 Docker images, so we don't only copy the parts we need for each executable and leave out the other libraries.
That is right, yes. Totally, yes. That's absolutely the way to go, yeah. What am I going wrong here? Can't stat home over, I did something wrong. No, that is... where does it fall over? So... Let's go get... okay. Sudo docker build. Can't state its own file. I don't have access to the home directory. Okay. This is related to my build environment because that's a bit messed up. Yeah. Okay. I'll give you 10 minutes until 1:15. I'll figure out my weird permission things on my image here, and then we'll build the image. Yep, please.
Could you, before the break, just recap what you've been doing and how?
Yep.
Just like because there's been not a lot of code.
Yeah. I was doing a lot of bug fixing here. So, yep. So, shall you recap now or later, or what's the?
Well, the most important thing is that there is a recap. So
yeah. Okay. Yeah. Just do once we have it running, I'll run you through the nitty-gritties of it.